Good morning. Welcome to class 9 mathematics. Today's the topic is lines and angles. So before going to start these lines and angles, chapter is taken from the geometry. So geometry is derived from the word geometry is derived from the Greek letter or a Greek word. Geo means earth, metron means measure. So measuring of earth is called geometry. So this geometry is one of the branches in mathematics. Example, even the statistics also is one of the branch in mathematics, geometry and so on. So before going to start, let us revise what you have learned in previous classes. The first is line. A line has no endpoints. Okay, example I am taking AB. This is the line that we are going to represent, and the next is line segment. A line segment has two endpoints and it is a part of the line. Example, I am taking this is the line segment AB. So it is going to be represented with A. The next one is ray. A ray has only one end point. So here is the figure. OA is a ray. It is represented with, in this way it is going to be represented a ray. OA is denoted with an arrow mark. The next one is collinear points and non-collinear points. See here, collinear points and non-collinear points. If three or more points lie on same line, if three or more points lie on same line segment, then these points are called collinear points. So example I am taking is the line segment AB. So in this, P is 1 point, Q is 1 point and R is 1 point. So here these 3 points are lying on same line segment, hence these points are called collinear points. And the next is non-collinear points. If 3 or more points doesn't lie on the same line segment, then those points are called non-collinear points. So here I am taking the figure here for the non-collinear points. I am taking this the figure here. So here these 3 points are not lying on the same line segment. So hence these 3 points are called non-collinear points. So the next topic is types of angles. So there are different types of angles. The first one is acute angle. What is an acute angle? An angle whose measure is less than 90 degrees. An angle whose measure is less than 90 degrees is called an acute angle. So I am taking the figure here. ABC. So this angle is less than 90. Hence angle ABC is an acute angle. The next is right angle. An angle whose measure is equal to exactly 90 degrees. Then this angle is called right angle. So here I am taking the figure here. PQR. So angle PQR is equal to 90 degrees. This representation is 90. The next one is obtuse angle. An angle whose measure is in between 90 and 180, that is more than 90 degrees and less than 180 degrees, then that angle is called obtuse angle. So here I am taking the figure here. So example, this is 90. So here this is the angle. It is more than 90 degrees and less than 180 degrees. Angle ABC is an obtuse angle. The next is straight angle or a straight line. So you already know about the straight line. An angle whose measure is exactly equal to 180 degrees. So that is called a straight angle, or we are going to say it as a straight line. So here I am taking. So this measure is equal to 180 degrees. Here angle AOB is equal to 180. It is a straight line or a straight angle. The next is reflex angle. What is a reflex angle? So your reflex angle means an angle whose measure is in between (180 and 360 degrees). Then that angle is called reflex angle. So here I am taking the figure here. This is the reflex angle. The next angle is complementary angle. So your complementary angles means sum of two angles should be equal to 90 degrees. Then those angles are called complementary angles. Example, I am taking angle X plus angle Y should be equal to 90 degrees. Then angle X and angle Y are called complementary angles. In the same way, I am taking the supplementary angles. So here I am taking sum of two angles. When I am adding two angles, then their sum should be equal to 180 degrees. So here angle P plus angle Q is equal to 180. So therefore angle P and Q are supplementary angles. The next angle is adjacent angles. So children, here adjacent angles means two angles are said to be adjacent if they have the common arm and vertex. So here I am taking the figure here. A, O, B and C. So here angle AOC is adjacent angle to angle BOC, because here these two angles AOC and BOC, OC is the common arm. So here the definition is two angles are said to be adjacent if they have common vertex and common arm. So here O is the vertex, O is the common vertex, and OC is the common arm. So here angle AOC is adjacent to angle BOC, or reverse, vice versa. So when I am adding these two adjacent angles, that should be equal to, may or may be equal to 180. Vertically opposite angles are formed when two line segments intersect each other at one point. So here I am taking the two line segments, one is AB and the next is CD. These two line segments are intersecting at a point O. So now angle AOD and angle BOC, these two are vertically opposite angles. See, these two are opposite to each other. In the same way, angle AOC and angle BOD are also opposite to each other. Hence, these are called vertically opposite angles. So here in this vertically opposite angle, when two lines intersect at one point, then vertically opposite angles are formed, and vertically opposite angles are always equal to each other. Now the next topic is intersecting lines and non-intersecting lines. Intersecting lines and non-intersecting lines. What are intersecting lines? The two lines, if they intersect each other at a one point, then those lines are called intersecting lines. Example, I am taking AB and CD. These two lines are intersecting at one point at O. These two are called intersecting lines. The next I am taking one more example is PQ and RS. So here lines PQ and RS are not intersecting. Hence these are called non-intersecting lines or parallel lines. Children, the next topic is pairs of angles. In that, the first one is linear pair of angles. When sum of two adjacent angles, is equal to 180 degrees, then they are called linear pair of angles. Example, here I am taking the figure here, AOB and C. So here angle AOC and angle BOC are adjacent angles, because see, OC is the common arm and O is the common vertex. So when I am adding these two, because AOB is a straight line, when I am adding angle AOC plus angle BOC, now it should be equal to 180, then only this is called a linear pair. Children, we'll start the exercise 6.1. In that, the first question is, in the given figure, lines AB and CD intersect at O if angle AOC plus angle BOE is equal to 70 degrees and angle BOD equal to 40 degrees. Then find the value of angle BOE and reflex of angle COE. So here I am drawing the figure. So here angle BOD is given 40 degrees. This is the figure angle. So here AB and CD AB and CD are intersecting at O, and the next is given angle AOC plus angle BOE, that means these two angles, angle AOC plus angle BOE is equal to 70 degrees and angle BOD is given 40 degrees. I have to find the angle BOE and reflex of angle COE. So here I need to calculate this BOE angle and COE angle. Reflex means from total 360 I need to subtract the COE angle, then that is called reflex of angle COE. So here, so we'll start the solution here. AB and CD are two line segments which intersect at O. Hence, AB and CD are intersecting lines and OE is a ray. And one more is given, angle AOC plus angle BOE is equal to 70 degrees and angle BOD is equal to 40 degrees. So these are given. Now I have to calculate this angle and reflex of COE. Now here AOB is a linear pair because it is a straight line. Now angle AOC plus angle COE plus angle BOE is equal to 180 because it is a straight angle. So here angle AOC plus angle COE plus angle BOE is equal to 180 degrees. Since AB is a straight line or a linear pair. Now angle AOC plus angle BOE, angle AOC plus angle BOE is 70 degrees. 70 degrees plus angle COE is equal to 180. Now angle COE is equal to 180 minus 70. Now angle COE is equal to 180 minus 70 is 110 degrees. Now angle COE, this angle is 110 degrees. Now I need to calculate the reflex of angle COE. So here reflex of angle COE is equal to 360 minus angle COE. Reflex means the angle should be lying in between 180 and 360. So here 360 minus 110 degrees, that's equal to 250 degrees. Now the value is reflex of angle COE is 250 degrees. The next is, so now this is also a linear pair because I know COE is 110 degrees and BOD is 40 degrees. Now I need to calculate the angle BOE. Now here angle COE plus angle BOE plus angle BOD is equal to 180 because it is a linear pair, because these are the adjacent angles and it is a straight line here. COD is a straight line. Now angle COE is 110 degrees plus I don't know the BOE value, then BOD is given clearly 40 degrees, that's equal to 180. 110 plus 40 is 150 plus angle BOE is equal to 180. Angle BOE is equal to 180 minus 150. Now angle BOE is equal to 30 degrees. Angle BOE is 30 degrees and COE is 110 degrees and reflex of angle COE is 250 degrees. So this is the answer for the first one. See the second question. In figure, this is the figure given here. In figure, lines X and Y xy and mn intersect at O. xy and mn are intersecting at a point O, and if angle POY is given clearly 90 degrees, and one more is given, angle A is to B is equal to 2:3, then I need to find the value of C. So here xy and mn are intersecting at a point O. Now POY is given 90 degrees. Now I need to calculate first. A is to B value is given. First I am going to calculate the value of A and B. Then later I am going to calculate the value of C. When the ratio is given, first we need to calculate the common ratio. Then I am going to find the values of A and B. So here the solution is xy and mn are two lines intersecting at O, and one more is given, angle POY is equal to 90 degrees, comma A is to B is equal to 2:3. So the ratio is given here, and clearly XOY is a straight line, hence angle POY plus angle MOP plus angle XOM is a linear pair. So before that, first I am going to calculate A is to B values, that means A value and B value. If the ratio is given, I am going to take the common ratio. Let common ratio be x. So therefore A is equal to 2x, comma B is equal to 3x. Now I got A value is 2x and B value is 3x. Now angle MOX plus angle MOP plus angle POY is equal to 180 degrees. It is a linear pair. Now MOX value is B plus A plus MOY is 90 degrees, that's equal to 180. B value is 3x plus A value is 2x plus 90 is equal to 180. Now 3x plus 2x is 5x. I am taking this 90 to right side. So 180 minus 90. So here 5x is equal to 90. Now here x is equal to 90 by 5. 5 ones are 5 18s are. X value I got 18. Now I am going to calculate the value of A. A is equal to 2x. That's equal to 2 into 18 is 36 degrees. So this value is 36 degrees, and B is equal to 3x. 3 into 18, that's equal to 54 degrees. B value is given 54 degrees. So here I have to find the value of C. I know the A value, B value, now I need to calculate the value of C. So for C value, MN is a straight line. MN is a straight line. Now, so angle MOX and angle XON are adjacent angles and it is a linear pair. Angle MOX plus angle XON is equal to 180 degrees because it is a linear pair. MOX, that is B plus C is equal to 180. B value is 54 degrees plus C is equal to 180. Now C is equal to 180 minus 54 degrees. C is equal to 126 degrees. Now I got the C value. When I am adding here, I am going to get 180 because I said clearly it is a linear pair. So children, A is equal to 36 degrees, B is equal to 54 degrees, and C is equal to 126 degrees.